Alright students, today we are going to look at part 2 of complex numbers. So just like the other day, when solving 5x squared plus 45 equals 0, that's a 0 right here, you would treat this as any other equation. So you want to get x by itself, minus 45 on both sides, minus 45. So you end up with 5x squared is equal to negative 45. Divide everything by 5. X squared equals negative 9. And to get that x by itself, well, we do the inverse, which is square root. So you got x equals plus or minus the root of negative 9. Notice how this square root has negative 9, so we can break that down into negative 1 times 9. And the root of negative 1 is equal to I. So I got I, and the root of 9 is just 3. So your answer is x equals plus or minus 3i. All right, feel free to pause that, understand it, and go back. Number 2, I have 9 plus 12i equals 3x plus 4yi. Solve for x and y. So in this problem we have two parts. We have the real part and we have the imaginary part here and here. Since I'm telling you that these two are equal, let's set the real part equal to the real part and the imaginary number equal to the imaginary number. So solve for x. The way we do that is basically just divide by 3 here, 3 here. X equals 3. All right, so that's the real part. Now, if I do the imaginary part, I want to solve for y. So notice how this is 4yi. I can rewrite this using the commutative property, which states I can write this as 4iy, and that's equal to 12i. Well, 4iy, that's basically multiplication, 4 times I times y. And the opposite of that is to divide by 4i on both sides. All right, so 4i divided by 4i is just 1y equals, here I have I divided by I is just basically 1. I end up with 12 over 4, which that's equal to 3. So coincidentally, both x and y are equal to 3. The next problem we have is very similar, looking for the x and y values. Same idea. We have a few things here. First thing I want to do is distribute this I. Notice I have 5 plus y equals all this. And before I distribute that, this right here is the imaginary number. This is the imaginary number here, and this right here, and this right here are the real parts. So I could set up an equation, 5 plus y equals 9. Solve for y, and y is equal to 4. So I get the 4 done. So what I got left is 3x minus 7 divided by I, or excuse me, multiplied times I equals 9. So distribute, so you get 3x I minus 7I equals 9. The idea here is to get x by itself. And doing it this way, it's not going to help me find the value of x. So instead of doing this, what I'm going to do is do not distribute the I. Instead, since I know this is multiplication, I'm going to divide by the I on both sides, and that will get rid of this I here. So I end up with 3x minus 7 equals 9 over I. All right, so I need to get this x by itself. All I have to do now is add 7, and And so I have 3x equals 9 over I plus 7. Divide everything by 3, divide everything by 3. X is equal to this weird looking fraction, 9 divided by I over 3 plus 7 divided by 3. But don't panic, we can make this more simplified. So you got 9 over I divided by 3. Remember that rule, that strategy that I taught you a while back when you divide fractions? Keep it, change it, and flip it. So when you do that, you end up with 27 over I plus 7/3. So this is what x is equal to. That right there is x. A little long, but I hope you can go back and see what steps we took to get x by itself. All right, on the left side we have another problem, add or subtract complex numbers. We need to find the like terms. So these two are like terms, 6 plus 4, well, that's 10. Then I have I plus negative 5i, that's equal to negative 4i. And I'm done with that problem. I got another problem. Let's simplify this weird looking fraction, okay? It's 5 over 3i. And a fraction cannot be simplified if it has an I or the imaginary number in the denominator. So what we have to do is we have to multiply everything by something called the conjugate. Okay? And that basically, it's almost the same thing as this, except it's the opposite symbol. So 3 minus I. We multiply that to the bottom and to the top, numerator and denominator. When you do it to the top, you have to distribute that 5. So you get 15 minus 5i over, well, let's use that FOIL method on the bottom. First, you get 9. You get the outer, which is negative 3i. Then we got the inner part, which is positive 3i. And then we have the last. I times negative I, it's negative I squared. Now recall that these two will be canceled because they're opposites. And also remember that I squared is just equal to negative 1 because I equals to root of negative 1. And if I have I squared, that's equal to negative 1, root of negative 1. Times root negative 1, which is equal to negative 1. So if that's negative 1 times a negative, well, that becomes 9 plus 10. And then on top I have 15 minus 5i. And actually this was 1. I'm not sure why I wrote 10. Everything is 10. 9 plus this became 1, everything is 10. And then let's simplify this even further. It's a fraction, so 15 tenths. 5 divides 15 3 times. 5 divides 10 twice. Minus, well, this right here, 5 tenths I is just 1/2 I. And that's your final answer. All right. You can pause that, try to understand it, and go back to your assignment. We got one last one. Same idea. Let's simplify this. Again, we cannot have any imaginary numbers in the denominator, so we have to multiply by its conjugate. And here, the conjugate is just minus 2i. Minus 2i. Same thing, distribute, so you get negative 14i plus 26i squared all over negative 4i squared. Notice that I squared is just, this is I squared is just negative 1. So negative 1 times negative 4 is positive 4. Same thing right here. That's negative 1. So you got negative 14i minus 26. You're almost done, except you have to simplify this all the way. So these two fractions are even, so I can say it's negative 7i over 2. These two are also even, so I can say it's negative 13 over 2. And that right there, ladies and gentlemen, is your final answer. This lesson was packed. Please take your time. Go back, understand it, replay if you have to. Otherwise, I will see you very soon.